Hi everyone, welcome back to another video in the Web Security Academy series. In the previous video, we covered lab number 8 in the SQL injection module. So we got some hands-on experience by exploiting a union-based SQL injection in order to query the database type and version on a MySQL database. In today's video, we'll be using a union-based SQL injection attack to list the database content on non-Oracle databases. If you do not have an account on the Web Security Academy, you can get one by visiting the URL portswigger.net/websecurity and clicking on the sign up button. I already have an account and I am logged in, so to access the exercise, I'm going to click on Academy, go down, select the learning path, go down, select SQL injection, select examining the database, go down one more time, and the exercise for today is titled SQL Injection Attack, listing the database contents on non-Oracle databases. So let's click on that. All right, let's get started. This lab contains a SQL injection vulnerability in the product category filter. The results from the query are returned in the application's response, so you can use a union attack to retrieve data from other tables. The application has a login function and the database contains a table that holds usernames and passwords. You need to determine the name of this table and the columns it contains, then retrieve the contents of the table to obtain the username and password of all users. To solve the lab, log in as the administrator user. All right, so we've got a couple of angles over here. The first one is we need to determine the table that contains usernames and passwords. The next one is to determine the relevant columns. And then once we have the table name and the column names, we will use that to output the content of the table. And then we need to log in as the administrator user. So the nice thing about this lab is that we're not assuming anything. So in previous labs, we were given the name of the user's table. We were also given the column names that contain the usernames and passwords. So in this lab, we're going to have to figure that out all on our own, which is more of a realistic scenario than the previous labs. Okay, so let's create an analysis section and access the lab. All right, so it looks like it's the same shopping application that we've been dealing with in the past couple of labs. You could refine your search based on a category. Once you do refine your search, so we're doing it for accessories over here, it'll only display the results that are related to this category, and that's done based on a field in the URL called category. And we know this field is vulnerable to SQL injection because the lab tells us. However, in a scenario where you don't know it's vulnerable to SQL injection, all you have to do is fuzz the application with SQL characters to see if it breaks a query at the back end. And it does. So we get an internal server error, which confirms that it's potentially vulnerable to SQL injection. All right, the thing about this category field is that whatever we enter over here gets displayed on the page. And what that means is that we could use a union-based SQL injection in order to display content from other tables in the database. And that's exactly what we're going to do. So I'm going to move on to using burp from now on because it's just easier when it comes to encoding. Let's close that, hit next, start burp. All right, let's put that over here for a bit and set Foxy Proxy to use burp. All right. Now, when I load this, it should be intercepted by burp, and it is. So what I'm going to do is I'm going to send this to repeater because I need to send this request a couple of times. And I'm going to turn my intercept off. Okay, so in order to exploit a union-based SQL injection, we said there's a couple of steps. The first one is to find the number of columns that the vulnerable query is using. So in this case, the vulnerable query is the one that filters on category. And the way to determine the number of columns is to use the order by clause. So order by and the column number over here. If we enter a column number that doesn't exist, it'll throw an error. So this way we could determine the number of columns that are being used by the vulnerable query. I can tell based on this that there's two columns, one for the title of the product and then the other for the description of the product. And so there's at least two columns, and let's confirm that with burp. So let's copy that, put it over here, do Control U to URL encode, hit send. And we get a 200 OK response. That means that this column exists, which again makes sense because I said that there's at least two columns based on the output that is on the page. So this one should also give us a 200 response code. So again, Control U to URL encode it, hit send, and we get a 200 response code. Let's try 3. And again, Control U to URL encode it, hit send, and we get an internal server error. So I'm just going to make note of that. What that means is that the number of columns that are being used by the vulnerable query is 3 minus 1, which is equal to 2. All right, the next thing to do is to find the data type of the columns. And the reason we do that is because the username and password are going to be of type text. And so in order to be able to output them from the database, we need columns that accept type text. And so let's see if any of these columns are of type text. And the way we do that is using union select null statements. So we know there's two columns based on the first step over here. And so what I'm going to do is we iteratively try each one to see if they accept type string. Now, if this is incompatible with type string, it should throw an error. If it's compatible, you should see the character A on the screen. Now, again, just based on the output, you could see that there's alphabets over here and there's alphabets over here. So they both should accept type string. And so instead of doing it iteratively, I'm just going to try both at the same time just to save a little bit of time. And let's try that. And I copied the wrong thing. Okay, Control U to URL encode it, hit send, and we get a 200 response code, and that's a good sign. So we should see our characters A somewhere. So you could see it over here and over here. So we make a note. Both columns accept type text. Okay, before we try to output content from the database, we need to figure out which database we're dealing with. And the reason behind that is because the query that you use in order to output all the tables in the database is different depending on the database. So one way to do that is to figure out the version of the database. And to do that, we're going to use the hint section in the exercise. So the SQL injection cheat sheet. You could see over here, database version. So on Oracle, this is the query that you do in order to output the version. This is Microsoft, PostgreSQL, and MySQL. Now, depending on which one actually gives us a 200 response and the version of the database, we'll know which database we're dealing with. But you could see over here that we're dealing with a non-Oracle database, and so we're left with 3 options: Microsoft, PostgreSQL, and MySQL. So let's start with Microsoft. And again, we need to fit that with our SQL injection. So it would be union, select at version, and then there's still another column. We could just put null in there. and comment out the rest. Let's try that. Let's do Control U to URL encode it, hit send, and we get a 500 internal server response. So I'm just going to make a note saying, not Microsoft. Next, let's try PostgreSQL. Again, we got to fit it in our union-based SQL injection. And let's test that out. And again, Control U to URL encode it, hit send, and we get a 200 OK response. And so we should see the version over here. PostgreSQL. Here we go. So that's the version of the database. So I'm going to make a note, say 200 response, 200 OK, and that it's a PostgreSQL database. All right, now that we know the database version, we could use that in order to output all the tables in the database. So that's our next step. Output the list of table names in the database. And the way to do that, we go back to our hints sheet and we go to section database contents, and it tells you based on the database how you could output the list of table names that are contained in the database. And that's why we needed to do step number 3, because you'll see over here each one differs based on the database you're dealing with. Now we're dealing with PostgreSQL, so this is the way to do it. So you've got the information schema.tables view, and what that does is it allows you to get the information about all the tables within a database. So we're going to copy that. And again, I need to fit it in my union-based SQL injection. So I'm going to say union, select, and we need 2 column names over here because that's how the union-based SQL injection attack works. So I'm going to copy this and just Google it to see the column names that are available to us. And I'm actually going to say PostgreSQL because it might differ. Click on columns. All right, so these are the column names. So you've got table catalog, table schema, table name, column name, and so on. So I care about the table name. So I'm just going to copy this one and put it over here. And then I'm going to say null because I don't care about outputting any other column in that table. So I'm going to copy this, put it in here, and do Control U to URL encode it. Hit send. And we get an internal server error, which means we did something wrong. And we forgot to do the comment. So hit send again, and we get a 200 OK response. So this should have outputted the table names that are available in the database. So you could see over here, there's PG partition table, PG available extension, and so on. I'm looking for a table that contains the user's word in it. And here we go. So you could see there's a table called users underscore and then some random characters. So I'm assuming that this is possibly my table that contains the list of usernames and passwords of the users of the application. We'll confirm that in a bit using the next step. And the next step is to output the column names of the table. So what we're trying to do is figure out which columns contain the usernames and passwords because we're going to need that in our end query. And to do that, we go to the hint section And you'll see over here for PostgreSQL, the way to do that is select star from information schema.columns, where table name is equal to table name here. So let's copy that. Again, it has to be part of our union-based SQL injection. So we'll add that. The table name is this one over here. And we need 2 column names. So to figure out the column names that are available, we'll Google it again and say PostgreSQL. Okay, so the view columns has these column names. So I'm interested in this one over here. So I'm going to say column name and null. Okay, so that should give me the column names that are available in this users table. So let's copy that, put it in burp, Control U to URL encode it, and hit send. Okay, 200 response code, which is good. So what I'm looking for is a column that contains the word username. That's good. So we've got this one over here, and then a column that potentially contains the word password. All right, and we found another one over here. Perfect. So now we know the table name. We also know the column name that contains the usernames and the column name that contains the passwords. And so we could put this information together in order to output content from this table. And so that's step number 6, which is output the usernames and passwords. And that's just a normal query. So let's have our union-based SQL injection payload. And then we say select this column and this column over here from this table. And comment out the rest of the query. So let's copy that. Put it in burp. Control U to URL encode it. Hit send. And 200 response. Again, that's a good sign. Let's see if it outputted the usernames and passwords. And it did. So you could see over here a username and a password. We're looking for the administrator user. And it's right over here. So I'm just going to copy all that and put it over here. Okay, so we've got the administrator's password. Now we can use it to log in as the administrator user, which is the last step in our end goal. Okay, click on My Account. Select Administrator. Copy the password. Click Login. And it says, congratulations, you've solved the lab. All right, so we've successfully completed the exercise. Now let's script it. Okay, the first thing we do is we import the request library. This will help us with sending post and get requests to the application. Next, we import the sys library and the URL lib3 library. Okay. We add this line over here to disable any insecure request warnings. .exceptions, .insecure request warning, and I'm missing an L over here. Okay, next set our proxy setting so that we can debug things using burp if things go wrong. So HTTP 8080, and we'll also do that for HTTPS. And what that does is any request sent through the script goes through burp first before it's sent to the application, and any response from the application goes through burp first before it's sent back to the script, and it helps us with debugging. All right, next let's create our main method. So if name is equal to main, and then try and accept clause. All right, so the way I want to run my script is it would be script.py, and it takes in one parameter, the URL. And the things that I want to do in my script are steps number 4 to 6. So I'm going to assume that I know the column numbers and the data types of the columns and the database that we're dealing with. It would be a fun exercise for you to write a script from scratch that determines all that. But for this one, I'm going to assume that I know that. And what I'm going to do is I'm going to script steps number 4, 5, and 6. So I'm going to first output the list of table names in the database, extract the table that contains the user's string, and then I'm going to use it in order to output the column names of that specific table, extract the names that contain the string username and password, and then I'm going to use those variables in order to output the administrator's credentials, which is a little bit more than we usually do. So this should be a fun scripting exercise. So let's take in one parameter from the command line, and that's the URL parameter. So sys.argv 1.strip. And then if I don't give it the correct number of arguments, I want it to print a nice message instead of an error. And the message says the usage instructions. So the name of the program and then URL. I also wanted to print example instructions just to make that really clear. Again, name of the program, and then let's say www.example.com. All right, and then I wanted to exit the program because we didn't run it correctly. Okay, so assuming that we did give it the correct number of arguments and we gave it the URL, then I wanted to print looking for a users table because that's the first step that we're going to do. And then I'm going to create a variable called users table and assign it to the return value of the function SQLI users table URL. So this is a function I'm going to write in a bit, and what that does is it outputs the table name of the users table. Okay, and then as long as that variable is not empty, it's going to print found the users table name and then the name of the table. So users table variable. If it's empty, I want it to print did not find a users table. Okay, let's save that. And now let's write the function that will figure out the table name of the users table. So def SQLI users table, and again it takes in the URL. First thing I'm going to set is the SQL payload, and that's equal to this one over here. So the payload that outputs all the table names of the tables in the database. Next, I want to perform my request. However, since we're going to be sending multiple requests, one for this one, and then one for this one, and then another one for this one, instead of doing it within every function 3 times, I'm going to create a function on its own that sends a request. So I'm going to call it perform request. And this way my code is much cleaner and there's less repetition in my code. So it's going to be perform request, URL, and SQL payload. And what that does is we first set the path to be equal to the path to the vulnerable function, which is this one over here. And then I'm going to make the request using the request library. And I'm going to say request.get. And the reason I say get is because this is a get method over here. And then it's going to take in the URL, the path, and the SQL payload. I'm going to set verify to be equal to false. And proxies to be equal to proxies. This way my request gets sent to burp. Okay, and then I'm going to return r.text. All right, so this function on its own, what it does is it takes in a URL and a SQL payload, and it just does a GET request using the URL and the SQL payload, and then it returns the response of the request. So I'm going to use that function over here in order to get the response. So I'm going to say res is equal to perform requests and give it the URL and SQL payload. So it'll use the SQL payload over here to perform the request that is used to output all the table names of the tables in the database. Okay, so the next thing to do is to filter the output and extract the users table. And to do that, we're going to use the soup library, which I haven't imported yet. So let's do that over here from BS4, import beautiful soup. And I'm also going to import the regular expression library. Okay, so I'm going to create a variable called soup, initialize it using the beautiful soup library, res, and HTML parser. And then I'm going to say the users table is equal to soup.find, where text is equal to re.compile. So I'm going to use a regular expression to extract it. And it's any number of characters, and then the characters user, and then again, any number of characters. All right, so what this does is essentially, if we go to proxy over here, HTTP history, and we did it through repeater, so it didn't get saved. All right, so let's go back to repeater and go back. Here we go. So it was this one over here. If we do users, this is what I'm trying to extract over here. So what I'm asking for is the characters users and any characters before and after. So what it should do is it should extract the table name over here. All right, so once that's done, I'm going to say if users table return users table, otherwise return false, and save that. All right, so in the script, we've completed step number 4. So let's run it and then try to do step number 5 and 6. So terminal, new terminal, Python 3, SQLi, lab 9.py, and this might have timed out. Let's run it one more time to see if it did, and it did. All right, so I'm going to close it and generate a new instance of the lab. and we don't need this anymore. Okay, copy the URL, paste it, and hit enter. All right, so it says looking for a users table and found the users table name users so and so. So you'll notice over here, this was randomly generated because it's different from the one that we got before. Okay, so we finished step number 1 in the script. Now let's do step number 2, which is outputting the column names of the table. And let's make that smaller. Okay, so once we found the users table and we print out the users table name, I need to figure out the column names of the table. And then I'm going to create 2 variables, so username column and password column. And those are going to be equal to the return values of a function that I'll create in a bit. So it's going to be called SQL users columns, and then it takes in the URL and the users table. So the name of the table that is returned in this variable over here. And then I'm going to say if username column and password column is not empty, then I want it to print found the username column name and then the name of the column. So username column, I'm also going to print found the password column name and the name of the password column. All right, and the reason I know it found both is because I use the AND operator over here. So if username column and password column are not empty, then print the following statements. Otherwise, print did not find the username and or the password columns. Okay, so let's write this function over here. So it was def SQLi and users columns. It took in the URL and the users table. And again, it takes in a SQL payload. And the SQL payload that we're going to use is this one over here. So the one that outputs the column names of the table. So in this case over here, we don't know the name of the users table. So we're going to use this and add it based on the variable that gets passed over here. So users table. Okay, next we're going to perform the request. And remember when I said I'm going to create a new function for it, perform request, and the reason behind that was because I'm going to perform a request in this one. I'm also going to perform a request in this one and then in the next step. And so I didn't want to write it every time. This way I could just call the function, perform request, give it the URL and my new SQL payload, which is this one over here. And then it'll output the response and save it in the variable res. Next, I want to extract the column names of the username and password columns. So we'll use the Beautiful Soup library for that again. And we'll say username column is equal to soup.find. Again, text.re.compile is equal to re.compile. And I'm looking for any number of characters and then the string username dot any number of characters. And then same thing for the password column. So let's say password and I'm looking for the string password. And then I'm going to return the username and password. And let's save that. So what this is going to do, if we go back and say username, it'll extract this over here, which is the column that contains the usernames. And then it'll extract this over here, the column that contains the passwords. All right, let's save it and run it one more time to see if it works. And we get an error at line number 33. Okay, and it's username column and password column, because that's what we called it over here. Okay, clear. Run it one more time. Okay, perfect. So over here, it found the users table. It used it in order to find the column names that contain the username and the column name that contains the password. Perfect. So we're done. Step number 5. Let's move on to step number 6, which is outputting the usernames and passwords based on this query over here. Okay. So once we found the name of the users table, and then we found the column names of the username column and the password column, the next thing to do, and I'm going to say step number 6, is to output the content of the users table. So to output the usernames and passwords of the users of the application. And to do that, I'm going to create a variable called admin password, say equal to SQLi. I'm going to create a new function called SQLi administrator cred, and it takes in the URL. It also takes in the users table, so the name of the users table, and it also takes in the name of the username column and the name of the password column. Now, if this is empty, so if admin password is not found, I want it to print. Sorry, if admin password is found, I want it to print the administrator password is, and then it prints out the administrator password, admin password. But if it turns out to be empty, I want it to print did not find the administrator password. Save it. All right, so now we need to create this function over here, which exploits the union-based SQL injection in order to output the administrator's credentials. So we'll add it over here. And again, it takes in the URL, the users table, the username column, and the password column. We'll start off by using our SQL payload. And we'll get that from over here. So this is different. So I'm going to say, so we'll extract that based on the variables that we pass. And same goes with this one. All right, so the first one is the users table. Next one is the username Oh, actually, the first one is the username column, because that's the one over here. And then the next one is the password column. And then from the users table, so users table. All right, so we need to make the request. And again, I'm going to use the function that I wrote over here. So this one over here to make the request for me. I'm going to give it the URL in the SQL payload. And then I need to extract the administrator's credentials from the response. And to do that, we'll use again the beautiful soup library. I'm just going to copy it from over here instead of rewriting it. Okay, so for this one, it's not as easy as finding a certain string because we don't know a substring in the administrator's password. So instead, we're going to use soup.body.find. So find the text administrator. And then once we find it, so let's go over here and say administrator. We could see that it's a th element, and then the one below it is a td element, and that contains the password. So in order to extract it, I'm going to say dot parent and then dot find next td and then the contents of the td element. All right, so what this does is it goes to the parent element and then it goes to the next td element, which should be the password, and then it extracts the content from there. All right, and then we say return admin password, and let's save that. Let's see if that runs. Let's clear this and run it again. So I get an invalid syntax error, and that's on line number 63. Okay, over here there shouldn't be a plus sign. Save that, run it one more time. Hopefully no more errors. And we do get one more error. So line number 40. Okay, it's because I copied it and forgot to rename the variable. So the variable over here should be called admin password. And I'm making mistakes because it's late, as you could see over here. All right, let's clear this and run it one more time. Perfect, no more errors. All right, so you could see over here, it looks for the users table. Actually, let's go to the proxy and look at the different requests that it made. And that's why I like passing all the requests that the script makes into burp, because this way I could see them. So I think it starts off with this one. Here we go. So this over here tries to find the table name. So it does that using the information underscore schema dot tables, and then it finds it and it extracts it and outputs it over here. Next, it does another request in order to find the column names of the username and password columns, which is done using this payload over here, and then it extracts it from over here. So the username table, so the username column and the password column. And then next it uses the users table and the column names in order to extract the administrator password, which is done using this request over here. And it prints out the administrator password. So let's try that and try to log in using that. Confirm that it's correct. So it's administrator. And the password is right over here. And that copied incorrectly. Hit login. And here we go. It says, congratulations, you've solved the lab. All right, so we've successfully completed the exercise. To recap, in this video, we first manually ran a SQL injection union attack that allowed us to list the database content on a PostgreSQL database. We then scripted the exploit so that it automatically does that for us. In the next lab, we'll learn how to exploit a union-based SQL injection vulnerability in order to list the database content on Oracle databases. If you liked the video, hit the subscribe and share button so that it reaches a wider audience. Also comment below what you learned and what you would like to see more of in the future. Thank you and see you in the next video.